Dear students, in the previous class we started deriving generating function of Legendre's function. Today we will discuss several important problems which are based over generating function. Question number 1, where we have to prove Pn1 equals to 1. As I already told you that we are going to solve the problem based over generating functions. We are starting the proceedings of solution with the standard mathematical statement of generating function of Legendre's function, in which we are substituting x equals to 1, by which left hand side becomes sigma n equals to 0 to infinite h power n Pn1, and right hand side becomes 1 minus h whole inverse, and hence the right hand side becomes the simple expansion 1 plus h square plus up to infinite, which is nothing but sigma n equals to 0 to infinite h power n. And hence by equating the coefficients of h power n both the sides of above equation, we simply get Pn1 equals to 1. Question number 2, where we have to prove Pn minus x is equals to minus 1 power n Pnx. It's an interesting one where we again start the solution with the mathematical expression of generating function, say as equation number 1. Now we substitute h by minus h in equation number 1, hence we get equation number 2 as shown there, and we substitute x by minus x in the same equation number 1, and hence we get equation number 3 as shown there. Now we can clearly observe that right hand sides of equations 2 and 3 are same. That simply means their left hand sides are bound to be same, and hence we get sigma n equals to 0 to infinite minus 1 power n h power n Pnx equals to sigma n equals to 0 to infinite h power n Pn minus x, and by equating coefficient of h power n, simply we get Pn minus x equals to minus 1 power n Pnx. Question number 3, where we have to derive several results like P0x equals to 1, P1x equals to x, then expressions for P2x, P3x and P4x. These all coefficients P0x, P1x, P2x, P3x, P4x, etc. are actually known as Legendre polynomials. So we have to find expressions for several initial Legendre polynomials as required. Now again, like previous two problems, we start the solution with writing the general expression for generating function of Legendre function, and then we change the right hand side with taking minus h as common. So the right hand side of second step of solution becomes 1 minus h into 2x minus h whole power minus half. So we can expand it binomially in infinite terms, which is written as 1 plus h by 2, 2x minus h, plus 1 into 3 upon 2 into 4, which is multiplied with h square into 2x minus h whole square, plus 1 into 3 into 5 upon 2 into 4 into 6 into h cube into 2x minus h whole cube plus up to infinite. And that simply looks like the left hand side, if we expand, becomes p naught x plus h p1x plus h square p2x plus h cube p3x plus h power 4 p4x plus up to infinite. And in right hand side, what we are doing, we are clubbing the terms of like powers of h. Like 1 is the first term of right hand side, where h power 0 is obviously there, and h power 1 can be obtained in only one term in above right hand side. If you see h by 2 multiplied with 2x minus h, so h by 2 into 2x will provide us h power 1, and it is the only possibility where we can find h power 1 in previous right hand side. So it's hx, and similarly we must try to find like powers of h, and we have to combine the terms of like powers of h, and hence we get the right hand side of current step h1 plus hx plus 1 by 2 h square into 3x square minus 1 plus 1 by 2 h cube into 5x cube minus 3x plus 1 by 8 h power 4 35 x power 4 minus 30 x square plus 3 plus up to infinity. And simply by comparing coefficients of like powers of h in this particular equation, the final solution is very much there. P naught x equals to 1 came as equating coefficients of h power 0. P1x equals to x obviously came as equating coefficient of h power 1, and similarly by equating coefficients of higher powers of h, we obtained results for P2, P3, P4. And in the similar fashion, we can find P5x, P6x, etc. if required. Question number 4, where we have to express a function of x, say px, which is given as px equals to x power 4 plus 2x cube plus 2x square minus x minus 3. And we have to express it in terms of Legendre polynomials. Dear students, Legendre polynomials, which I told you in the solution of previous question, question number 3, that p0, x, p1x, p2x, etc. were Legendre polynomials. So we have to express px in terms of p0x, p1x, p2x, etc. And we actually can use the solution of previous problem, question number 3. And if we have to solve this particular problem independently in any kind of examination, it is required that you have to solve the question number 3 before starting the solution of question number 4. Now we are using it directly. So we have x power 4 equals to 8 by 35 p4x plus 6 by 7 x square minus 3 by 35. It obviously came as per the expression of p4x in the previous solution. Similarly, by using expressions of p3x, p2x, p1x and p0x in previous solution, we obtained expressions for x cube, x square, x and 1 in next line of the solution. And using all these expressions repeatedly in px equals to x power 4 plus 2x cube plus 2x square minus x minus 3, I am using the term repeatedly. It means, first of all, you have to substitute the value of x power 4 in right hand side of px. Then it is expressible as 8 by 35 p4x plus 6 by 7 x square minus 3 by 35. Now 6 by 7 x square is to be added with 2x square, which is already available in px, and 2x cube is obviously there, and minus x minus 3. That means next you have to use value of x3 in terms of p3x and x. Similarly, repeatedly you have to substitute x cube, x square, x and value of constant 1. And hence by combining these all, by doing some simple mathematical exercise, finally you will find px is equals to 8 by 35 p4x plus 4 by 5 p3x plus 40 by 21 p2x plus 1 by 5 p1x minus 224 by 105 p0x, where obviously p0 x, p1x, p2x, p3x and p4x are Legendre polynomial, as I already told you in the solution of question number 3. So students, here we finish this section of solving several very important problems based over generating function of Legendre function.